All right. When we talked about permutations, the single most important thing that you needed to know about permutation is that order was important. You had to not only select the objects, the R number objects up from N, you also had to put them in order. All right. Today we're just looking at combinations. So you're just choosing, in this case, from a set of objects without having to worry about the order in which that they're placed. Okay. Now, combination, NCR. Sometimes you'll hear myself say it, or they'll say it if you're watching other videos. They'll say N choose R, and that basically is what that's telling you is that word choose is going to lead you out of a permutation and into a combination. Okay, and so NCR looks very similar to the NPR formula. And the exception is we have to then divide by the number of ways in which we order those R objects that we've selected. So NCR and NPR look exactly, very, very much the same, except I have to add in this division of R factorial, which just represents the number of ways in which you can order those R operations. All right. All of the diamonds from a standard deck of playing cards are shuffled, and four of these 13 cards are dealt in a row. How many different permutations of 4 diamonds can be dealt? Okay. So a permutation, it basically says that. So actually what we need to do is our main focus today is going to be on deciphering what words lead us to permutation and what words lead us to a combination, because that gets kind of dicey or tricky. All right, it's sometimes hard to see that. In this case, that they specifically ask you for the number of permutations. So there's 13 hearts in a deck, and you're selecting 4 of them and ordering them. So you'd have 13 P4. All right. So 13 factorial over 9 factorial. All right, remember it's 13 subtract 4, which is 9, which leaves you at 13 times 12 times 11 times 10. And then you would calculate that at 17,160. All right. Now it says, suppose the order does not matter. How many different combinations could be dealt? Okay. So now all I need to do is select out of that group 13, choose 4. One other thing I want to point out is another way to write that is that way. You'll see that in the workbook. 13 over 4 with the round brackets. That means 13 C4. That means 13 choose 4. That means a combination of 13 C4. Okay, it means the same thing as NC4. Or 13 C4 NCR, sorry. Okay. So in this case, I flipped it. Sorry, I lost my train of thought because I flipped the page by accident. So in this case, I actually have 13 factorial over 9 factorial, 4 factorial. I've selected the 4. I don't care about their order, so I'm going to divide the order out. So the number of ways in which you can order 4 cards is 24 ways. So I divide that out of this. So I take 17,160 divided by 24, and that equals to, now there's only 715. So I remember I showed you yesterday the differences, yesterday, the day before, the difference between having to select the 6 numbers out of the Lotto 649 and putting them in order compared to the number of ways in which I just select 6 from 49. And it's quite significantly less, right? The number of ways you can actually select something is considerably less than the number of ways you have to select them and order them. All right, so that's the one thing that you want to remember. Now, there are 2 types of questions that become that you're going to see frequently. And those are the questions on page 106. Okay. How many subcommittees of 4 students can be formed from a student council consisting of 7 students? Okay. So, in there anywhere, does it say anything about order?
No.
No. Does it say anything about specific positions on the committee? No. So if that's the case, then you are just simply choosing 4 from 7. That's it. So that is 7C4. Okay? So that's important that you understand that there is not, I had that in the wrong order. 7, 1, 3 off, 3 factorial, 4 factorial. Okay, so if I'm just selecting, so nowhere in there does it say I have to select the 4 on the committee and order them. Nowhere in there it says I need a specific person or treasurer, president, whatever. I don't need that. So then I'm just selecting 4 from 7. Okay, so 7 factorial over 4 factorial will leave me with 7, 6, 5, just like that. And then that's over 3 times 2 times 1, and those cancel, leaves me that. That gives me 35. Okay, so again, you're able to use your calculator. I don't care if you use your calculator. I'm just trying to do this and show you that it's actually can be done fairly quickly without the use of technology. All right, now the next question is the one that you're going to see frequently. So this is the one you want to make a note of and you want to follow along. At Karina's birthday party, there are 7 boys and 9 girls. Karina has to choose 6 children to start off a party game, including at least 1 boy and at least 1 girl. In how many ways can she do this? All right, so I need at least 1 boy and at least 1 girl. So the first thing I want to do is I want to write out all of the scenarios that I can possibly have. All right. So this type of question, when they use the word at least, I am going to show you 2 ways in which to do it. One that's quite a bit longer and one that's quite a bit shorter. All right. So the first thing I'm going to do, and I should do this almost every time in these questions. First of all, I look at how many kids do I have total. So how many kids are there total at this birthday party? 16. And how many am I selecting for this party game? 6. So let's find out the number of ways I can select 6 from 16. That's the very first thing I want to do. I want to find out the total number of ways with no restrictions, 6 from 16. So get your calculators out, punch that into your calculator. And what do I get?
8,008. 8,008.
8,008? Like that? Thank you. Okay, so there's 8,008 ways. Now I want to check, I want to look at the scenarios that can possibly happen now. All right, I need at least 1 boy, 1 girl. So what are all the possibilities that can happen? All right, I'm selecting a committee of 6. So
1 boy and 5 girls.
excellent, that's a good start. That's what I wanted. 1 boy, 5 girls.
2 boys.
4 girls, right? 3 boys, 3 girls, 2 boys.
No, 4 boys.
Oh, 4 boys. 2. 4 boys, 2 girls, 5 boys, 1 girl. Okay, so those are all the possibilities. All right, without writing anything else down, just put your pencils down because I'm going to show you the long way, which is not the way I would recommend. Okay, so I'm going to do that. Bless you. I don't think that you want to do it. I think I'm going to show you a quicker solution than this. But here's how this works. Each one of these represents a case. So now I have to actually find out how many ways each can happen. So how many boys do I have total in this group at this birthday party?
7 boys.
7. So here's what I've got. 7C1 times 9C5 equals 7C2 times 9C4 equals 7C3 times 9C3 7C4 times 9C2, 7C5 times 9C1. There is the total number of ways that I can select 6 from a birthday party in which I have at least one boy and one girl in this case. So now I have to punch that all into my calculator. I have to find out what 7C1, 9C5 is and multiply them together. Then I have to do 7C2, 9C4, multiply them together. You following? Okay. Now, I said to you, there is a little bit easier way to do this question. So I'm going to show that to you right now, and you'll probably much prefer it. So I'm going to go back to this guy again. So the total number of ways in which I can select is 8,008 ways, right? So what I'm going to do then, anytime you hear the word at least, I'm going to subtract the alternative from it. So what is the alternative from having at least one boy or at least one girl?
No more than one boy?
No.
At least
One boy and 5 girls and 1 girl and 5 boys.
No, because it's at least one, right?
At least.
So what's the alternative to that? What's the
no
only
more than 4.
No more than.
what's the only 2 scenarios I don't actually have here right now?
No less than 1 girl.
0 and 6 and 6 and 0. Correct? Those are the only 2 cases I don't currently have, right? So those are the only 2 possibilities that can occur without having at least one boy or one girl. So what I'm going to do then is I'm going to subtract those 2 scenarios from it. So I have 8,008 minus 6 boys, no girls. Oops, I don't want that. I want this. I guess I got to subtract
Let's
again.
use brackets.
Unless I use brackets, that's right. Okay, so then the alternative is that. What's 7C0 and 9C0? Quick, 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 quick. What is it?
1.
Get off your calculator. It's 1.
Can't be 0 because then it'd be nothing.
How many ways can you choose nobody?
7,917.
How many ways can you choose nobody from a group? There's only one way to do that. There's only one way to choose everybody from that group too, isn't there? So if I was choosing 6 from 6, there's only one way I can do it. Choose all 6. There's only one way I can do none of that group. 0 out of the 6. Okay? So here's what I have then. 8,008, subtract 7C6, subtract 9C6. What do I get? Now I want your calculators working. Anybody come up with an answer yet?
7,917.
Anybody not get that? So that's taking 8,008 minus 7. Math. Go over to probability. NCR 6. Subtract 9. Math. NCR 6. And then hit equals.
8,008, that's just representing how many ways that you didn't have to have at least one boy or at least one.
Yeah, if there's no specifics there. You're just simply picking 6 from 16. Yes. All right. That's combinations. This is the type of question you're going to see often. is a committee type question. And again, if they had at any time specified that at this party they needed a president, a vice president, a secretary, whatever, that's order. Now you're changing your question to a permutation. So it's important that you know the difference between the two. Okay? All right, that's all I had for today. That's just for those that are going to finish up 4.4 today. Okay? Everybody's through 4.3, I'm expecting. That should have been done. Through 4.3. We should be on 4.4 and then through that by the end of today. Okay? Questions from that page? Go ahead.
2 from 4.4. The first one is page 102, question 6. And then the second one is 103, question 7, and then just do one of them so I know how to do the other one. I was a little confused.
I have questions.
Yeah. 6 is
Okay, Garrett
mentioned.
works at a video rental store. He has 6 copies each of 3 different new DVD releases to put on the shelf. And how many ways can he arrange the DVDs on the shelf? So how many DVDs does he have total?
18.
18. And if 6 are the same, so he has only 3 different movies, right? So
Yeah.
18 factorial over 6 factorial, 6 factorial, 6 factorial. That's it.
Oh, I put
Six.
6 on the top and then 3, 3, 3. That's why I
That's
made
the
my
total
mistake.
divided by ABC.
Mm-hmm.
6 on
Okay, so far? Yeah? All right. The B part is an interesting part. This is something that you wouldn't probably get on your own without help. So we're going to look at it. Let's say I now put them together. So I have A, B, C now. So A represents the first 6 movies, B represents the next 6 movies, and C represents the last of the 6 movies. In how many different ways can the DVDs be arranged if the copies of each one must be grouped together? So now we're grouping them together into 3 sets. Okay? So now this changes things. Now I'm looking at it, all right? And I'm saying, okay, well, now I'm basically only arranging 3 sets here, right?
Yeah.
I'm gonna put these together, these together, these together. So I've got, how many choices do I have here? So ACB, BAC, BCA, CAB, and CBA. So how many ways can I arrange those 6 movies? There's only 6 ways in which I can arrange the movies, right? If I'm going to group them together. Correct? So far, so good?
Yeah.
Okay, I need to look up. I want to make sure I've got the, what is this, 4.3?
Or no, 4.4 actually.
4.4?
Yeah, you're right.
Question 6B.
Okay. We all right? Okay, so the reason that changes from this is in that one, I can put any of them in any order out of the 18. They don't have to be together. But as soon as I specify that I have to group the 6 together, I now only have 3 factorial ways of that happening. Okay,
Um,
all right.
Yeah, that makes sense now.
Any questions about it so far? That makes sense? Okay, there's one other question that is very similar to it. I don't know where it is, but it must be in the review. Okay, number 7, in a set of n objects, there is one subset of 3 identical objects, and the rest are all different. Investigate the pattern of the numbers of arrangements of these n objects. Make a statement about the pattern as n increases. So you have 3 objects, there's only 1 arrangement. You have 4 objects, there'd be 2 arrangements. There'd be the group of 3 and then 1 other.
Okay.
If you have 5 objects, there would be 3 arrangements.
Oh, so the group of 3 must stay together, but you're adding 1 on every time. So it's adding a different group.
Yes.
Okay, I just read the question wrong.
Okay. How do you do on 5?
I got it wrong.
We're gonna do it.
I got very
You have none yet?
confused.
Okay, so your kind of pre-calculus way of doing it isn't gonna help you here. Because they're not all lumped together, all right? So you have to kind of do it, if you're looking at the A part, you gotta start on A, you have to lump them, you wanna do the lines and get it to the bottom there.
Oh, I went from B to A. Does that make a difference?
Yeah.
Oh,
So you have to, you have to.
Like say you
did.
can only go west and south.
How many routes are there from A to B?
Yeah.
Okay?
there's only one way. Like, same direction. Good practice for your cheat sheet.
Making progress.
Yeah. Great though.
Now I need, now I need a,
3 by 1.
all right, so I have color here.
Oh.
That's not gonna work.
Is that how you draw the lines?
Can you make the box?
You have to do it.
Yeah, that would.
We can do the lines differently.
There's a warm over there? Like,
Uncomfortable.
and like literally only just a comfortable temperature.
I left a note on the back page too,
Yeah.
expressing my feelings.
I think it was like the question was like, what could make his school better? I said fix the school heating. Explanation point. Didn't put anything else. The divisions needs to cool down.
Wouldn't you draw them like this way? Yeah.
Why does it matter which one?
That's what my name, it wasn't.
Oh, never mind.
That's where you start.
Yeah, I just, yeah. When I use the thing that made the green one.
Oh, they're pretty straight.
Doesn't it feel like a Friday?
It's Thursday.
I know, but technically it's a Friday.
Well, it's technically the third Thursday.
Guys, technically it is a Friday because we don't have school.
It's 3 days till school's next, so that's a Monday.
Yeah, I know that, but it's just.
Whoa,
Okay.
guys.
That's not
So,
good.
if you're doing this question, all right, I'll get you to the bottom here. We go 1 all the way across here. You always start with your outside, and then 1 down. Okay? Then I got 2 here. And then 3 here. And 4 here. All right? 3 there, 6 here, 10 here, 4, 10, 20, 5, 15, 35, 6, 21, and 56, right?
56 only.
But you're only allowed to move, south and west.
Yeah.
Oh, but that's going
Okay, so
forward, that
I'm
makes
right
sense.
there. Now this is the point in the question right here where you have to know what to do.
56.
That's right. So it's 56 down here, 56 right here, 56 right here, and 56. Oops, too far on the board here. 56 right there. Now you add them. 56 and 56, 112, 168, and then that, which would give you 204, 224,
And the answer key says 140.
something like that. I don't think the answer key is right on this question.
No, that's for number 4, no,
No, that's 5A.
Huh. Interesting.
This is how you have to get through that question,
Okay, thank you.
okay? I'm gonna leave B for you. All right, is there anything else this morning? We're at 11.
Steps to breaking something down after you boil it, like 8 times get your sum, A, or A and C, sorry.
Are you looking at that same question you were just doing? So what did you have on top? N minus 1, N minus 2 equals 12,
Yeah,
okay? So I have N squared minus 3N plus 6. Oh, 2, I did that yesterday too. Plus 2 equals 12, you have that, right?
yeah, and then
Hey.
that's about it.
All I can hear is you in the background. Sit quietly, please. So at this point, I gotta get it equal to 0, right?
Oh,
There. Okay, can you go from there?
probably not.
Now you're factoring.
Yeah, that's my, how did I factor? I do the sum first.
So I have that, right? What are the factors of N squared?
And
And what are the factors of negative 10 that add to give you negative 3?
But if it like wasn't, if N wasn't just 1, then I would have to times the 2 right?
Negative 2 and 5.
Yeah, you have to
Yeah,
go
that's
through. Yeah, but you're, in these questions though, that you won't have, there'll be no factoring with A values that aren't 1.
Then negative 5 and 2.
We're doing it the other way around, where if you did negative 2, then.
Yeah.
No, because you need negative 3.
Oh, yeah. I didn't see that.
Okay, so what's your answer?
5 and negative.
5, because you can't have N as a negative value.
Right, so I put the negative 2 there. That's called an extraneous root. Remember that? And then I have to exit out. I have to show it and exit out. Okay? All right, you got 20 minutes. You need to be done to the end of 4-4. And actually, you know what? You need to be done to the end of 4-5, bless it.
Yeah, 4, 5 is on the same page.
4-5 is only 5 questions, so get that done, please.